তোমরা শুনতে পাচ্ছ? হ্যালো।
হ্যাঁ স্যার।
আচ্ছা, তাহলে শুরু করছি। হ্যাঁ, তোমরা শুনতে পাচ্ছো?
হ্যাঁ স্যার।
দেখতে পাচ্ছো?
হ্যাঁ স্যার।
আচ্ছা, ঠিক আছে। Previously, we discussed state space search. My question is this: why state space search is necessary? Answer in a single statement. Why state space search is necessary? Respond, please. Don't hesitate. Respond on the basis of what you know.
To reach goal state.
Our ultimate objective is, why do we need to reach goal state? Because we need to solve a problem. We want to generate a solution of a problem automatically with the machine, isn't it?
Yes sir.
What is the input to a state space search algorithm? Basically, the state space implicitly defines state space of a problem that is provided as input to a state space search problem, and what we get as at the output, we get a sequence of rules which, when applied over the start state, will eventually produce the goal state. Just think of 8 puzzle problem. What was the output for an instance of 8 puzzle problem to a graph, to a state space graph? What will be the output? Please answer. If we supply an instance of 8 puzzle as an input to a state space search algorithm, what will be the output? Respond, please. Please respond. Your answer will, yes.
And the steps required to reach the solution state of the 8 puzzle problem.
Goal state, not solution. That is the solution. That constitutes the solution.
Yes,
isn't
sir.
it?
Yes, sir.
So why do we need state space search or graph search algorithm for searching the state space? Because we want to generate a solution of a problem automatically. Isn't it?
Yes, sir.
And to avoid huge consumption of computational resources which cannot be supported by a practical system, under AI we use knowledge-based search. We apply knowledge-based search to make the search shortcut, to make the search intelligent, to make the search directed towards the goal. And all these we do to generate a solution automatically for a problem. Isn't it?
Yes, sir.
Acha. Now the question is this: when I started to lecture first, I illustrated state space search with several problems. Can you name those problems? Can you mention those problems which I discussed in illustrating state space search other than 8 puzzle?
Sir, Tower of Hanoi.
Yes. Another problem.
Hill climb.
Hill climbing search is a search method.
Sir, block wall problem.
Huh?
Block world
World
problem.
problem. Another problem,
Traveling salesman.
traveling salesman problem. Now, all these problems require to encode a problem state with a suitable data structure. In case of 8 puzzle, a problem state could be encoded with a two-dimensional array of integer type. In case of Tower of Hanoi or in case of Tower of Hanoi, it could be encoded as a list of integers, a state representation. In case of linked list, it can be represented, a state can be represented as a list of cities so far visited by the salesman. Isn't it?
Yes, sir.
Now let us think of another problem. That is, let us assume that we have a database. Database means a collection of information about certain domain. And if you provide a query to that database, what you will expect? You will expect an answer from that database. Now, it may so happen an answer to your query may not be directly matched with the data stored in the database. It may be derivable from the data stored in the database. For example, there may be some data in the database like this. John is a man, and another group may be there. Maynard, man is mortal. Let this be a database. Let this be a database. Now, if I ask a question, is John mortal? Can it answer? Can it answer?
No, sir.
It cannot answer. But to answer this question, if we apply the rules of logical inference, then this query can be answered. For example, John is a man, so John is mortal. This kind of inference can be done.
Yes, sir.
So we can write John is mortal. This is a very simple example. So this is called intelligent information retrieval. This is an example of intelligent information retrieval. That is, you want to retrieve certain fact which is not directly available in the database, but which can be derived with the facts and rules stored in the database. Such kind of application is called intelligent information retrieval. Mathematical theorem proving. At the high scale level, you have proved several theorems relating to plane geometry. Now, how those theorems were proved? There was a set of axioms. We can think of an automatic mathematical theorem proving system in this way. Initially, it stores the set of axioms and a statement of a theorem. A statement of a theorem is supplied as input to this, and in return, it will supply a proof for the theorem using these axioms. A proof consists of what? A proof consists of a sequence of inferences which begin at the set of axioms and which end at the statement of the theorem. Can you follow this?
Yes, sir.
So this is another kind of application where state space search can be applied, but we have not yet discussed how state space search can be applied in such application. Robot problem solving. This is again another kind of applications. Actually, in all such applications, problems requiring encoding of descriptive statements in state space. So if we want to encode descriptive statements in state space, the data structures of which we have so far discussed, like arrays, sets, linked lists, trees, this will not do this job. We cannot use these data structures to encode descriptive statements in state space. So we need some other method of encoding natural language sentences inside a computer, firstly. And secondly, we also need rules to draw inferences from the existing facts or existing statements. And for that, we need first order predicate calculus. আচ্ছা এটা মুছে দিচ্ছি।
হ্যাঁ স্যার।
I summarize what I discussed earlier. Number one, state space search is an AI methodology. For what? For finding a solution of a problem automatically, or generating a solution of a problem automatically. State space search is a methodology. It is an AI methodology, because under state space search, we not only search for a solution in the state space, we can guide the search using knowledge to make it directed towards the goal, to avoid huge computation. We can apply knowledge. So state space search, number one point is this: state space search is a general methodology for finding solution to a problem. Number one. Number two is this: if you want to solve a problem using that state space search methodology, in that case, firstly, that problem must be solvable. That means there should at least be one solution to that problem. Secondly, you need to encode the problem states, various problem states inside the computer using suitable data structures. You need to encode various problem states inside the computer using suitable data structures, so that the state space search algorithm can work.
স্যার স্যার সিটিটা কি অনলাইন হবে?
হ্যাঁ
স্যার সিটিটা স্যার অনলাইন হবে?
তুমি বাবা কোথা থেকে এলে বলো তো? তুমি কোথা থেকে এলে? তোমার নাম কি? শুভ্র বোস। এখন
না স্যার, আমি না।
আলোচনা হচ্ছে। কে প্রশ্নটা করলো, নাম কি তার? এখন আলোচনাটা কি নিয়ে হচ্ছে? তুমি কি সিটির জন্য ক্লাসে এসেছো? এক্সাম রুল দেখে নেবে সিটিটা কিরকম ভাবে হবে। ক্লাসে ডিস্টার্ব করবে না একদম। এক্সাম রুল দেখবে কি কি আছে সেটাও তো জানো না। Very frustrating experiences I am having from you. Quite frustrating. There are 91 or 92 students are in this class. They are not attending the classes. And on occasionally they are coming and they are raising such questions just to create disturbance in the class. Am I discussing on this topic now? When I asked a question, accepting one, no one answered. Completely non-cooperation you are showing to us. What kind of decorum it is, I do not know. City will be conducted as per the exam rule. Go and check the exam rule. What is there? I do not have the power to decide how the city will be conducted, in what mode. I am not in a position to decide on that. So don't ask me that question. This is about first order predicate calculus. It provides unambiguous, precise representations of natural language sentences. It provides rules of logic to generate or infer new sentences from the existing ones. That is, it can generate new sentences which are logically consistent with the existing ones by using those rules of logic. And then it is needed for representing descriptive statements as problem states in a state space. And once descriptive statements are represented with problem states, new states can be generated using the rules of logic, and logical inferences can be drawn. So, so this is in a nutshell about first order predicate calculus. Is there any question?
No, sir.
Okay.
স্যার একটু বাঁ দিকে সরে যাবেন?
লিখে দেবো এটা?
হ্যাঁ স্যার।
হ্যাঁ স্যার।
First order predicate calculus is also sometimes called first order predicate logic. So these are the major contents of first order predicate logic. That means when we study first order predicate logic, we will be studying in details on these two topics. First one is syntax of predicate calculus sentences. That is how we can form predicate calculus sentences. Such sentences formally called well-formed formulas. And then we will learn rules for drawing inferences from predicate calculus sentences. That is how we can generate new sentences which are logically consistent with the existing sentences. And this we will be able to do by using rules of logical inferences. মুছে দিচ্ছি।
হ্যাঁ স্যার।
এসেছিলাম কিছু ডায়াগ্রাম গুলো আমরা অ্যাড করলাম তো ভালো যদি সময় হয় আপনি দেখে নেবেন ঠিক আছে ওটা সোমবার আচ্ছা সোমবার আচ্ছা আমি জানি আজকে ভালো যে বসে ভালো করেছো ঠিক আছে সোমবারে এসো ঠিক আছে
So these are the elements of first order predicate logic. To know first order predicate logic, we have to study all these elements individually. Firstly, alphabet. It is basically a set of symbols. It is basically a set of symbols. Predicate symbols represents relation in a domain of discourse. Say, to explain how these predicate symbols represent relation in a domain of discourse. Let the relation be authorship. There is a set of authors, set of people, and a set of books. Let us consider two sets. One set consists of the names of various people. Rabindranath is there, Valmiki is there, Homer is there, Aristotle is there, and there is another set of books, Gitanjali, Ramayana, Iliad, Homer, and we want to define a relationship, authorship. And for this, let us use a symbol like this: author of. Say, author of Iliad, Homer. And somebody has written author of Iliad is Aristotle. let us, instead of idiot, let us consider what is this. This should be Odissi. এটা ভুল ছিল, এখানে অ্যারিস্টটলের নামটা ভুলে গেছিল। Say this is a predicate. Say this is a predicate. A predicate symbol. Here we have defined a predicate symbol as author of, and it has two arguments. These are the arguments of the predicate. তোমরা বোর্ড দেখতে পাচ্ছো?
হ্যাঁ স্যার।
So there is a predicate author of Odyssey, comma Homer. Now, according to the relation defined on this domain of discourse, this predicate will have a true value. This predicate will have a true value. But this predicate, author of Odyssey, comma Aristotle, this predicate will have a false value, because between Aristotle and Odyssey, authorship relation does not hold in this domain, but between Homer and Odyssey, authorship relation holds in this domain. So this will have a true value, this will have a false value. So predicates in predicate symbols in first order predicate logic represents relation in a domain of discourse. Can you follow this?
Yes sir.
আচ্ছা, এটা মুছে দিচ্ছি।
হ্যাঁ স্যার।
Next, terms. Terms in predicate logic may be constants, may be variables, or may be functions. Now, constants means such entity will not change their values. Here, Odyssey is a constant, Homer is a constant, these two are constant. I have not yet shown the example of variable here. If I use a sentence like this, every book has some author. If you want to represent a sentence using predicates in predicate logic, every book has some author. it represents a general rule. So for all x, book x implies there exists someone who is author of x. So here we show the examples of variables. These x and y are variables. So constants, these are constant, Odyssey, Aristotle, variables. Function. Function, I am showing an example of function. সেটা মুছে দেবো?
স্যার ডান দিকেরটা একটু ছেড়ে দিও।
হ্যাঁ, লিখে নাও।
স্যার হয়ে গেছে।
Let us consider a sentence like this. Let there be a sentence, father of John is married to mother of John. We do not know exactly who is father of John and who is mother of John. But we have a function. Given value of given some value of its argument, it will return its father's name. We also have another function, mother of. Given the name of some person as its argument, it will return the name of the mother of this person. So with these two, we can represent this sentence with a predicate married to. Again, this predicate represents a relation. That is father of John, comma, mother of John. And this John is here an example of a constant. So this example I am showing you to explain what are constant, what are variables, and what are functions, and what is a predicate.
স্যার এখানে ভ্যারিয়েবলটা কোনটা?
এখানে ভ্যারিয়েবল নেই, সব জায়গায় ভ্যারিয়েবল থাকবে জানো।
আচ্ছা
আগেরটা ছিল
আচ্ছা আচ্ছা।
every book has some author.
স্যার একটু সরে যান।
হয়েছে?
হ্যাঁ স্যার।
these atomic formulas. Predicate plus term. It constitute atomic formulas. What are the examples? The examples is man, John. That is, John is a man. This is an atomic formula. Author of.
Sir, term technique?
A constant is called a term, a variable is called a term, a
আচ্ছা,
function
বুঝতে
is
পেরেছি।
a common name.
Okay, sir.
Term is a common name for constant, variable and function.
Okay, sir.
So these are two examples of atomic formulas. Predicate and terms constitute atomic formulas, and these are the building blocks of well-formed formulas. So well-formed formulas are one or more atomic formulas. Combined with one or more combined with connections. One or more atomic formulas combined with connectives. Now, before I define atomic formula, I should define what are connectives. Connectives are operators like and, logical operators like and, or, not. So, connectives are Boolean operators like and, or, not, and implication. Now about and or not, you possibly know.
Yes, sir.
Okay. And about the implication, you need to know something. I shall explain it later. Okay, let me explain it first. Now this formula is read as P implies Q, where P and Q are two predicates and this is an implication. Now, how do we define the logical value of this implication? Actually, we should draw a truth table. Now, in an implicational formula, the portion of the formula belonging to the left hand side is called antecedent and the portion of the formula belonging to the right hand side of the symbol is called consequent. And this is the truth table. This truth table is formed on the basis of this equivalence relation that P implies Q is equivalent to not P or Q. And if you go through this truth table, you will find that if antecedent is false, irrespective of the truth value of the consequent, the implication will have a true value. If antecedent is false. And if antecedent and consequent both are true, then implication will have a true value. But if antecedent has a true value and consequent has a false value, then implication will have a false value. That is only under one situation this implication will have a false value. That is, if antecedent is true but the consequent is false. Now usually this implication is used to represent certain rule. I may define a rule like this.
স্যার একটু বড় করে লিখবেন।
I will define a rule like this. If black cloud appears, there is rain. And we can use an implication to represent this rule. Like now, if we find that black cloud appears over the sky, but it is not raining, that means this rule is false. So if antecedent is true, but consequent is false, then this rule is false. And if antecedent is false, then irrespective of the truth value of the consequent, the rule will remain true. That means if black cloud does not appear over the sky, then this antecedent will be false. So irrespective of whether it rains or not, the rule remains true. And if antecedent is true and consequent is also true, then the rule also true. That means if black cloud appears over the sky and it rains, then this implication will have a true value. So this is how we can remember the truth value of an implicational formula. Only under one situation this will have a false truth value. That is when antecedent is true and consequent is false. And in all other cases it will have a true value. বুঝতে পারলে?
হ্যাঁ স্যার।
আচ্ছা, তাহলে what is well formed formulas? One or more atomic formulas combined with connectives. আমি দু একটা एग्जांपल দিয়ে এবার এই connectives কাকে কাকে বলেছে and or not and implication এটা বুঝবো?
হ্যাঁ স্যার।
Let there be a sentence. If someone can swim and play football, then he or she is an athlete. And in predicate calculus, well formed formula, this can be written as using three predicates, can swim, can play football, athlete, we can represent this sentence in predicate calculus well form formulas. Here, this is an atomic formula, this is an atomic formula, this is an atomic formula, and they are combined with connectives. So this is an example of a well-formed formula. A well-formed formula consists of one or more atomic formulas like this. These are the atomic formulas combined with connectives. ঠিক আছে?
হ্যাঁ,
ঠিক
স্যার।
আছে?
হ্যাঁ স্যার।
আচ্ছা। Then rules of inferences. এটা মুছে দিচ্ছে, এগুলো সব মুছে দেবো।
হ্যাঁ স্যার।
বোর্ড পড়া যাচ্ছে তো?
হ্যাঁ স্যার।
আচ্ছা, রুলস অফ ইনফারেন্সটা বলার আগে আমি একটু দুটো জিনিস বলে দিতে চাই। This example I used previously. It represents a sentence that every book has some author. Now here two variables are there. One is x and other is y. Now in predicate calculus expressions or well-formed formulas, no variables without quantification can appear or will be allowed to appear. In predicate calculus, well-formed formulas, no variable without quantification will be allowed to appear. Allow করা যাবে না. So, if there is a variable in a predicate calculus well-formed formula, this must be quantified, and this kind of quantifier is called universal quantifier because it represents all values of x for all x which are book, and it represents some value of x. That means for all book x there exists some author y who is author of x.
Yes, sir. Understood.
So this is what we mean by quantifiers, and there are two kind of quantifiers. One is universal quantifier, other is existential quantifier. এটা মুছে দিচ্ছি।
হ্যাঁ স্যার।
বোর্ডের লেখাগুলো পড়া যাচ্ছে?
হ্যাঁ স্যার।
Can you tell me what is a well formed formula?
Sir, one or more atomic formulas combined with connectives.
What is an atomic formula?
Sir, predicate plus term.
Predicate plus term constitute an atomic formula. All right. Now we are discussing about properties of well formed formulas. Firstly, connectives like and or, they are associative, commutative and distributive. Should I explain the meaning of associative, commutative and distributive?
Sir, not required.
Not required. Okay. And De Morgan's laws hold for well-formed formulas. Possibly all of you know of De Morgan laws, or should I explain it?
Yes, sir, I know.
You know, but there are others. You studied logic in the first year.
Yes, sir.
What about others? So that they know it. De Morgan's law. Nilargo, you know?
Yes, sir.
Anirban, do you know? Anirban, are you here? Akanka Mukherjee, yes sir, will you? Akanka, which stream do you belong? In which department do you belong? EPC. Anyone from civil engineering or chemical? Anyone from civil engineering or chemical in this class now?
Yes, sir, I know.
Jyotirup.
Yes, sir.
You know De Morgan's law?
Yes, sir.
Okay. Then contrapositive law, that is, if there is a well-formed formula P implies Q, it is logically equivalent to not Q implies not P. That is, how to recollect, how to remember it? Exchange the antecedent and consequent part of this implication and then put a negation before the antecedent and the consequent. So these two are equivalent. This is called in logic contrapositive law. Now here are also some equivalence relations applied on well-formed formulas. Now if there is a well-formed formula for all x px is true, and if it is preceded by a not symbol, that means for no x px is true. That means there exists some x for which not px is true. So these two are equivalent. Can you follow me?
Yes, sir.
So then for all x px is true, it is exactly equivalent to for all y py is true. We are simply replacing these variables, but we are not changing their quantification. It is universally quantified here, and in the right hand side also it remains universally quantified. We are not changing the predicate. It is px, it is p, it is p. Now similarly, for existential quantifier, there exists some x px is true. If this be a well-formed formula, it is equivalent to for some y py is true. Now this formula for all x px and qx is true. It is equivalent to for all x px is true and for all y qy is true. And this for some x px or qx. For some x px or qx, is true, it is equivalent to for some x dx is true or for some y qy is true. So this equivalence relation holds for the pair of universal quantifier and operator. For the pair of existential quantifier and operator. So you will recollect it. You will try to remember it. দেখো ঠিক হলো হলো
হ্যাঁ স্যার।
কোনো কোশ্চেন আছে?
না স্যার।
আর একটুখানি পড়িয়ে দিই আর 10 মিনিট মুছে দিচ্ছি সব।
হ্যাঁ স্যার।
আচ্ছা আর একটা টার্মিনোলজি বলা হয়নি, বলে দিই। This is again a terminology of predicate calculus. Literal.
স্যার এটা কি টার্মস এর পার্ট?
হ্যাঁ, টার্মস এর মানে কি? প্রেডিকেট ক্যালকুলাসের বিভিন্ন আর কি টার্মিনোলজি।
হ্যাঁ হ্যাঁ।
So literals are atomic formulas or they are negation. This is an atomic formula. Predicate plus constant. Man, John. That means John is a man. And this is another atomic formula. Preceded by a negation. That is not athlete John. So John is not an athlete. So these are the examples of literals. An atomic formula or its negation is called literal in the context of predicate calculus. Next we will discuss rules of inference. if there are two well-formed formulas, one is W1, another is W1 implies W2. With these two well-formed formulas, by applying modus ponens, we can infer W2. This is a rule of inference of predicate calculus. That is,
একবার বলবেন?
if we have two well-formed formulas, one is W1 and the other is W1 implies W2. These are two well-formed formulas.
Yes, sir.
Now, with these two well-formed formulas, by applying modus ponens is a rule of inference of predicate calculus. We can generate a new well-formed formula, that is W2.
Okay, sir.
Next is universal specialization.
স্যার রুলস অফ ইনফারেন্সের নিচে ওটা কি লেখা?
হ্যাঁ। এটা W2.
Modus
না
ponens.
না, আচ্ছা মোডাস।
MODUS PONENS. Modus ponens.
আচ্ছা আচ্ছা ওকে।
It is a rule of inference of predicate calculus. This is an inferred well-formed formula. This is another inference rule of predicate calculus, that if there is a well-formed formula of this form for all x, Wx is true, and if we can find such substitution, that is A upon x, it is a substitution. It is called substitution. Presented as a term by variable. So if we can find one such substitution, and if we apply it over for x, all x, Wx, we will get a new well-formed formula Wa. This is called universal specialization. It is another kind of inference rule available with predicate logic. ঠিক আছে?
হ্যাঁ স্যার।
আচ্ছা মুছে দেবো?
স্যার ইউনিভার্সাল স্পেশালাইজেশনটা ছেড়ে মুছে দিন।
হ্যাঁ।
ইউনিভার্সাল স্পেশালাইজেশনটা ছেড়ে মুছে দিন।
আচ্ছা তোমরা লিখে নাও।
স্যার একটু সরে যাবেন। স্যার হয়ে গেছে।
there are two sentences. Man John, it is an oil-form formula. Another oil-form formula is for all x, man x implies mortal x. So here, to apply modus ponens, we need to match the antecedent portion of this implication with some well-formed formula. But here we cannot match directly the antecedent portion of this implication with this well-formed formula. So we are introducing a substitution, that is John by x. And if we apply this over this well-formed formula by universal specialization, what we will get? We will get man John implies mortal John. Now, this is a well-formed formula that we have derived by using universal specialization. Then if we consider this well-formed formula and this one, we can combine these two using modus ponens. To produce another new sentence, that is John is mortal. So this is a combination of universal specialization and modus ponens.
Yes, sir. Understood.
Can you follow this?
Yes, sir.
Yes, sir.
ঠিক আছে, আজকে এই অবধি থাক। এবার বলো ক্লাস টেস্ট নিয়ে কি বলছিলেন, বলো কি বলছিলেন।